In this video, we're going to make our dumb parcel locker a smart parcel locker. And we're going to do this using an ESP8266, HomeAssistant, and some other things we have laying around from other projects. Now, about this parcel box. We have a kind of a long driveway with entry gates, which are normally closed. And to reduce the amount of packages that were carelessly left down by the street, we installed a parcel box, which is basically nothing more than a truck toolbox attached to our fence and propped up by some structural stones. The goal for the project is to make the box notify us if there's a package inside via HomeAssistant. We find ourselves coming down here to check this box an awful lot, and sometimes there's nothing there. And yes, I know, I can already hear it now in the comments. That's kind of a lazy person's problem. Yeah, I get it, but hear me out. This is an opportunity for kind of a fun project, probably. Something that's interesting, and heck, we might even learn something along the way, so that's neat. Now, in case you're following along at home, or in case you want to build this project for yourself, I'm going to leave a link down below the video in a section called Useful Links for all the pieces and all the parts that you're going to need to do this project yourself. So I'm thinking how I want to go about this is, I think I want to have a D1 Mini and a 12-volt shield, looks like this, and maybe a time-of-flight sensor. That's what I'm thinking. And I think the idea might be that we mount all these maybe side by side on a piece of breadboard or a piece of prototyping board, and we keep the whole profile just as thin as we possibly can, so it doesn't hang down. Because I think what I want to do is I want to take the whole conglomeration and mount it to the ceiling of my parcel box. And the time-of-flight sensor basically is just a little IC that emits a freaking laser beam. It'll see the laser bounce back, and it can calculate the distance to the object based on the bounce back time. So for example, if our time of flight is measuring 1 meter from the sensor to the bottom of the parcel box, we can now write an if then. You know, if the distance is 1 meter or greater, then no package. But if the distance is less than 1 meter, then package. Unless they deliver them like that, I think that will be a pretty simple kind of a binary yes or no. It either is in there or it isn't in there. So I think that's the direction we're going to go. The first thing we're going to do, though, is I'm going to go ahead and get our 8266 module loaded out into HomeAssistant, and we'll get it provisioned, and we will do our time of flight sensor. We'll put that together, and we'll do just maybe a couple of quick sanity checks here to make sure that what we're thinking is going to work. All right, with that in mind, let's take our D1 Mini and let's plug it into our workstation, and we'll get ESP Home fired up, and we will throw an image on this so that we can get to it wirelessly. We're going to jump over to Device Mangler, and we're going to make sure that it has a COM port assigned, and it is COM20, so we have it. So now we'll jump over into HomeAssistant, and we'll go ahead and add this. And in order to add this, we go into ESP Home, and we're going to create a new device, and we're just going to continue here, and let's name it Parcel Locker. Let's name it Parcel Box. That seems better. Next. And this is going to be an ESP8266 in my case. Yours may be different. And this encryption key, I'm going to go ahead and copy it, but typically we don't need it. So we'll click Install. And we're going to say that it's plugged into this computer. Remember the whole COM20 thing. And I'm going to download the binary, and we'll just open ESP Home after that, and we'll just stick it on there. All right, now that that's done, we'll click here to download it, and we'll see it jump up here. Obviously, Google Chrome doesn't know what to do with this, so we're going to say keep it. It's safe. We know it. And there's our binary file. So we're going to open ESP Home Web. Once we're in here, we're just going to tell this to connect, and it should find our COM20 here. And we'll do connect. I'm going to install the downloaded project because that's the one we just downloaded here a second ago. So install. And we'll choose a file. In this case, we'll use our parcel box binary. and install. At this point, it's erasing the device, and it'll upload the new binary to it, and this thing should come up and go. Now we're installing the binary out to the D1 Mini. When it's finished, it should reboot, and we should have a device that we can attach to wirelessly. All right, we're done. We'll close this, and we'll also close ESP Home Web. And I can close this because I'm finished with it. So let's click on logs, and we're going to connect to this wirelessly. Now keep in mind that our D1 Mini has already attached itself to the Wi-Fi that we specified, because when you initially set up ESP Home, you have a secrets area here that you can include the Wi-Fi SSID and password that you'd like all the new devices to automatically connect to. And we've already done that. So we should be able to click wirelessly, and it will connect. It looks good. Now, at this point, we're not doing anything. Now let's go in, and we're going to edit our parcel box. And this is the YAML file, which basically is where we put everything extra that we want it to do. In this case, I'm going to change this. I'm going to change this right here from ESP01_1M, the board type, and we're going to change that to D1_Mini. The next thing we're going to do is we're going to jump down, and we're going to set up our I2C. Here we need to specify a couple of things. We need to tell it which pin is SDA and which pin is SCL. In the case of our D1 Mini, pin D1 is going to be SCL, and pin D2 is going to be SDA. So we'll tell it SDA is GPIO4, and SCL is GPIO5. We're also going to say that scan is true, because we want this to scan through the addresses each time it starts up, because we don't know what address that our time of flight sensor is going to get assigned. But if I put scan equals true, then I can watch the logs as the D1 Mini boots, and I can find out what the address is. And that should take care of the basic of I2C. So at this point, we're going to save this. Now, it's very important that just because you save this, it doesn't mean that it sends it up to the device. So you have to click install. And we're going to choose wirelessly, and that will send everything up to our D1 Mini. Now that we have our image on this, the next thing we want to do is we want to go ahead and install our time of flight laser sensor and find out what its address is, what its I2C address is. That's why just a second ago, when we were putting in our YAML file, the scan equals true. That's so that each time this machine comes up, it will do a scan on the I2C bus and basically list the device address of everything it finds on the bus. There can be more than one thing. So we're just going to take some DuPont cables and just quickly plug this thing up to our D1 Mini. So we have DuPont cables, we have our time of flight laser, and we have our D1 Mini and some glasses because, well, we can't see. All right. So the D1 Mini can put out either, it can put out 5 volts or 3.3 volts. And in the case of the time of flight sensor, it says it can run on, it just says voltage in. So we'll use voltage in, and we'll use ground. We'll use the black one for ground. So there, I have my red lead to VN, and I have my black lead to ground. We can put these in the corresponding sections of the D1 Mini. So the red will go under the 3.3. The black will go into the ground. And that has the power requirement satisfied for this. The next is we'll take SCA, and we'll have to look on the front to see which one SCA is. SCA is the fourth one over, so SCA goes here. And SCA is going to be D2 on the D1 Mini. And that leaves D1 for SCL. There. So now we have power, ground, SCL, SDA, all hooked up to our D1 Mini. For right now, we'll just power our project with our little GPD Mini Pocket 3. GPD Pocket 3, not a Mini Pocket 3, but you know what I mean. All right, we should be able to plug this in. And at this point, the I2C should be running, and we should be able to look at the logs and find what the address is. At that point, we can finish setting it up and create our sensor inside HomeAssistant. Back into HomeAssistant and back into the ESP Home section, we'll click on Logs of our newly created Parcel box here. We'll choose to get those logs wirelessly. All right, and we can see that we did an I2C bus scan, and we found a device, and its address is 0x29. So that's what we need to remember. Using this 0x29, we can go in and we can create our time of flight sensor. So we'll close here, and we'll edit this. In order to create a sensor in ESP Home, we tell it that we're about to create a sensor. Then we have to tell it which platform. That begins with a dash. In this case, it's going to be V15310X. Did I type that correctly? V153, yeah, there we go. Excellent. We're going to tell it the address is 0x29, which we saw earlier. Next, we should give this sensor a good name. Let's say name, and I don't know, distance, for example. We can name it whatever we want. Next thing we should do is give it an update interval. Now, you got to be careful with this because if you update it too quickly, you're just going to waste a lot of data, and you're going to waste a lot of electricity, especially if you're powering your project by battery. So let's say update interval, and for testing purposes, we're going to do 5 seconds. We're going to change this for sure before our project goes, oh look, I didn't type that correctly. PDATE, update interval 5 seconds. Okay, so this is going to report back every 5 seconds. This will be really handy during testing, but we'll have to remember to go back and set this to something more reasonable, like, I don't know, maybe check every 5 minutes or something like that. We'll work on that as we get closer in. So let's save this, and then we're going to install up to the D1 Mini. Now we're back online, so let's go and look at our logs again, and we'll do this wirelessly. And here we go. So at the very bottom, we can see what our sensor is sending every 5 seconds. Distance of 0.536, 0.568, so it's moving around a little bit. And rather than look at it here in the console, let's go and look at it inside ESP Home. So we'll close this. We'll go over to Settings, and then we're going to go to Devices and Services. And we can see here that HomeAssistant has already discovered our test parcel box. So let's configure this. And we're going to add this to HomeAssistant, submit. The encryption key, do I still have that? I do, submit. All right, finish. So now when I go into my ESP Home, I'll see that I have 4 devices configured here. And here's our parcel box.
And we basically have one sensor that we care about, and that's the distance sensor here. So it's moving between 0.52 and 0.60. So let's install it a little more sturdily and see what we get.
This is the madness that I currently have going on. As you can see, I have my my solder gun holding stand, or my soldering station here, and I have my D1 Mini back there in the back, and I have some wires clipped here, and this is my time of flight sensor, and it is looking at this, and we can see that it is moving between 0.53 and 0.50, maybe 0.54. I have it approximately 18 inches above the surface of my desk. If I take a package, like this package, for example, and put it in the path there, we can see that our distance goes down to 0.46 or maybe 0.47 meters. When I add another box, we're down to 0.43 meters. So with this in mind, I have enough basic information to create my conditional card within HomeAssistant. So let's remove these boxes, and we'll get our distance back up to maybe 0.50 to 0.54. And I'm thinking that we have the conditional card say anything less than 0.50 means there's a package. Anything more than 0.50 means there's not a package. So let's go create that part.
Now, in order to create our conditional card, we have to, it would be easier to make it a binary choice, either yes or no. In other words, yes, we have a package, or no, we have a package. So one of the easiest ways of doing that is by creating a helper, and that lives under Devices and Services. They're helpers. So in Devices and Services, we'll go to Helpers, and we're going to create a helper. And in this case, we're going to choose a threshold sensor, because if our distance meets a certain threshold, then we want, something to happen. So let's call this Parcel Box Switch helper switch. So it's basically going to be a switch. And we're going to call this, so the sensor we're going to use here is going to be parcel box distance. And basically I can say the lower limit that I want is 0.49. Anything above 0.49 will result in that switch turning on. And we're going to say that this lives at the gate. Finish. And we can look currently and see that our threshold sensor is not turned on, because we told it 0.49 to turn on. But if we put a big box in front of it, we can see that it just turned on because it went below that 0.49 value that we specified. So let's remove those boxes. We'll turn our switch back off. This is where that 5-second update interval comes in extremely handy. So let's jump back out to our overview. In this case, I have an info section in HomeAssistant. This is just where it's kind of a playground where I test things so it doesn't muck up our home screens. So let's go up and let's add our conditional card. To do that, we're going to hit the ink pen or pencil. We're going to add a card. And I'm going to use a conditional card because I only want this to be displayed if my helper that I just made is turned on. So conditional. And we're going to add a condition. And we're going to say when the entity state, and I'm talking about the entity parcel box helper switch that we created earlier, is set to, is it currently, yeah, there you go, is set to on, then I want a card to be displayed. I think I want to use a mushroom card for this. Just a very simple mushroom title card. There we go. And I don't have to do anything crazy. I just want to say delivery in parcel box Very, very simple. And I think I'm going to center that because it'll look a little bit better. We'll save that and we'll hit done. Now that card is gone. And when I put my deliveries back under it, delivery and parcel box shows up.
Well, our proof of concept shows us that it's actually very simple to make what we want to happen. But the next thing is, how are we going to power this? One of the quickest ways might be to just use this 18650 battery shield. And while that's great and all, the ESP home devices tend to really eat battery. So without doing a lot of stuff like putting it into deep sleep and only waking it up every couple of minutes to check, without getting into a lot of that, it may be simpler just to power the thing by using one of these. This is just a 12 volt power input shield. And I had this one kind of kicking around, and I've soldered these headers to it because sometimes I stack a lot of these modules together and do various testing with them. In the case of this one, it could easily just plug right onto the top of our D1 Mini and, have a little stack. Now, the question is going to be, if I mount this in the roof of our parcel box, is it going to stick down too much? And I think the answer may be yes. What we may do instead is get one of these and get a small piece of breadboard and basically just maybe solder these to the breadboard and solder our time of flight laser beside them and keep everything as flat as we can possibly keep it. That's probably what we're going to do here, I would think. So let's get a piece of breadboard out and let's lay these components out on it and try and decide how we want this to look. Well, I have this this collection of prototyping board here, and I believe I'm going to use the piece a piece that's about this size. And I think I'm going to place my components on here something like this, possibly. Maybe I can make some kind of sleeve or something that this thing can like maybe slide and lock into on the ceiling. And but either way, in order to put this in this board, I need to put some of these standoffs on there, and so I'm going to solder those on here. This is not the D1 Mini that we were using before. We were using this one. We were using this one to do our testing with, but it already has these soldered to it. And since I'm looking to have the smallest and slimmest profile possible, I decided to draw a fresh one out of my supply, and we're going to use this one. So so the first thing I need to do is get all of my pins soldered on there, and I found that really the easiest way to do that is to take your pins and just stick them into a piece of breadboard like this. I'm not even putting them all the way in there. You can solder them up at that point, and then you can pull them out when you're done. It keeps everything from getting all wobbly and crazy. So let me solder this up. That one's soldered up. All right, that's got both of those soldered up. And I think maybe what we'll do is put this here and maybe this here. The USB port on this kind of makes it a bit problematic. It sticks out a long way. So if I'm going to do this correctly, I'm going to have to make it stand off some. If I'm going to mount this board the way I'm considering mounting this board. I guess it really doesn't make any difference. I can always make something that goes this way, possibly. Mount our laser here, for example. Yeah.
Let's make something that looks like this.
So this is my finished product. This is what I've basically come up with. I 3D printed myself just a small stand with 4 screw holes that go through it. I think those are like M2s. But what I did in order to make it, like attached to the ceiling, I made a recess here for one of these bar magnets. This is one of those rare earth magnets that sticks just incredibly good to everything. Has a really good hold to it. Hopefully what I'll be able to do is just plop that thing up in the ceiling and the magnet will be way more than sufficient to hold it. I mean, it really, really grips. So obviously this thing's going to have a power wire coming out of it, a barrel connector. The way I'm going to attach that is using these. They're basically like zip ties with a base on them, but you can tighten them up, but you can actually take them back off again pretty easily. 3M foam tape, and it holds. I've had about 6 of these on the outside of the windshield of one of my trucks now for 3 years in the rain and elements, snow and all. They still hold up. So have no doubt they'll hold up just fine in the roof of a closed and sealed parcel box. Hopefully. So I'll see you down at the parcel box and we'll make this project come to fruition. This is the finished product. Ended up with the 8266 right there, and basically we just ran our wire all the way down the inside, and we used way too much goop back there to seal it, and the wire comes out of the box and is directly buried. I use low voltage landscape lighting cable that's meant to be directly buried in the ground all the way over to that black box right there, which has power and a switch and some more things for the gate. Also, you see 2 antennas sticking up on there. That's a Wi-Fi AP for the services down here at the gate, which means that the ESP8266 can easily get to Wi-Fi, even with the door closed, surprisingly. Let's see this baby in action. Well, we have our phone here with the HomeAssistant dashboard up and going. So we'll open our locker and we'll throw a package in. Delivery and parcel box. So we've accomplished our goals. Our parcel box is now smart, so project well done. Thanks for watching, guys. I appreciate it very much. And if you haven't already subscribed, please do so. Like the video, and I welcome any comments you have or anything else that we can do around the place to make it smarter. I'd love to hear that also in the comments. So till next time, thanks for watching.